Welcome to Graphing Logs. Remember yesterday we talked about that logs are the inverse of exponentials. So today we're going to talk about and compare graphing logs to graphing exponentials. Bear with me, this is a new program. Okay, so first, here are your parent points of an exponential, or of a log. That we know exponential, our asymptote would be y equals 0, and now we have x equals 0. That our first parent point in exponential was 0, 1, and now we have 1, 0. And then our other parent point for exponential was 1 in the base, and now we have the base of our log, and then 1. So we're going to use the same rules that we did for graphing an exponential. Except for now we're going to have the inverse coordinates. So just like before, we have to make sure and write down what our parent points were. So instead of 0, 1, it's now 1, 0. Instead of 1 in the base, it's now the base and 1. And if you remember, the base of a log is the little number down there. So it's now going to be 3, 1. And then instead of y equals 0, it's now x equals 0. So the only other number besides the base we have to worry about is this minus 2 in the parentheses with the x. So if you remember, because it's inside the parentheses with the x, it does affect the x value, and we have to do the opposite. So instead of subtracting 2, we're going to add 2 to each of the x values in the coordinates. And this time, my asymptote is an x value. So we end up with the coordinate 3, 0. 5, 1, and x equals 2. So we're going to go ahead and graph that over here. 3, 0, 5, 1, and x equals 2 is now going to be a vertical asymptote. And then our curve is now going to go this way, and it's now going to go down. When we talk about our domain and range, if you remember, the range of an exponential was your asymptote. Well, in this case, we're going to flip it around. Our domain is now our asymptote. So since it was x equals 2, it's now going to be x. And since the graph is going over here to the right, it's going to be greater than 2. And then for our range, since in the last ones your domain was all real numbers, our range this time is going to be all real numbers. And that's graphing a log. Let's go ahead and try this one more time where we have some different numbers. Again, we have to start off with our parent points. So we start off with the coordinate 1, 0. And we have to look at the base. So it's the base, which in this case is 5, 1, and then x equals 0. So this case we have two numbers. We have a 3 over here and we have a 2. Because there is no parentheses with the x, neither of these will affect the x. It will affect the y. Just like exponential, we start with the number that's multiplying. So in this case the 2, so we have to multiply all the y values by 2. So since the asymptote is not a y, it just stays the same. So we have the coordinate 1, 0, 5, 2, and x equals 0. And then we're going to go ahead and deal with that 3. Again, because it is not in parentheses with the x, it does not affect the x. Since it's adding, we're going to put a plus 3 with both of the y values. And we now get the coordinate 1, 3, and 5, 5. And again, none of this affected the x values, so my asymptote is still x equals 0. So we're going to go ahead and graph these points. 1, 3, 5, 5, and the asymptote x equals 0, and we graph our log. So again, those 2 points show you which direction that your curve angles, and then we go vertical as we get closer to the asymptote. So again, let's talk domain and range. Remember your domain, because our asymptote is now x, is going to be your asymptote. Since it points to the right, it's going to be greater than 0, again, not a greater than or equal to, and then your range will be all real numbers because it is going up and down. And that's all you have to do to graph a log.